everyone. Today we are going to learn how to solve radical equations when there are radicals on both sides of the equations. Before we get started though, I want you to expand each of the following expressions using patterns. So the patterns that you're going to see here for A, B, and C are going to be your perfect square trinomial patterns and your Liouville patterns. So these patterns are not going away. They will certainly be on your final exam. They will also be very helpful for today's lesson. So please go ahead and pause the video and solve or simplify each of these expressions by expanding them. And when you have an answer, please go ahead and restart the video. All right, let's go ahead and look at letter A. So the letter A, we have x minus 3 squared, which means that our answer will be a perfect square trinomial. Our pattern goes like this. This is the one where you take your first term and you square it. So that's going to be x squared. The sign in between is a minus. Then you multiply 3 times x, that's 3x, and double it. So 3x plus 3x is 6x. And then finally, negative 3 squared is positive 9. So there's your answer, x squared minus 6x plus 9. Letter B is also going to provide us with a perfect square trinomial, where once again we're going to be working with the same exact pattern as letter A. So 3x squared, that's 3 times 3, which is 9. So 9x squared. The sign in between is a plus, so we write a plus. 3 times 2 is 6, and we double that. 6 plus 6 is 12. So we have a 12x. And finally, 2 times 2 is 4. So our answer is 9x squared plus 12x plus 4. For letter C, these are Liouville situations. Our answer is not going to be 27x cubed minus 1. That is not our answer. Instead, this is a Liouville. That's your 1, 3, 3, 1 pattern. Then you go 3, 2, 1, 0, 0, 1, 2, 3. So I'm going to write out 1, leave a little bit of space, 3, leave a little bit of space, 3, leave a little bit of space, and then a 1. I'm going to write down my first term, which is 3x, and I'm going to raise it to the third term, then 3x, raise it to the second, third power, second power, then 3x raised to the first power, then 3x raised to the 0 power. Then I'm going to take my next term, which is 1, and I'm going to raise it to the 0 power, the first power, the second power, and the third power. Now, because this is a minus, we have to alternate our signs, positive, negative, positive, negative. So now I'm going to simplify each expression individually. So 3 to the third power is 27, and so I have a 27x to the third power minus, working with my exponents first, 3 squared is 9, and 9 times 3 is 27, so minus 27x squared. Plus 3 to the first power is 3, and 3 times 3 is 9, so that's 9x. Then minus anything to the 0 power is 1, so we have a 1 to the third power, which the answer is 1. And there's your answer, 27x cubed minus 27x squared plus 9x minus 1. Hopefully these patterns were okay for you, or at least a really nice refresher. Like I said, they're not going away. They will certainly be on your final exam, and we can even use some of these patterns for our lesson for today. Now, our learning objective for today's lesson is to be able to say that I can solve equations with radicals on each side of the equation. They're on each side of the equation. So that's a little bit different than what we learned in the last lesson. Then I want you to be able to say, I can identify extraneous solutions of the equation. Now, because I kind of write big, I'm going to draw horizontal lines separating each equation so that I have my space in between, and this might be helpful, especially for those of you who write big just like me. So, just like before, we needed to have our radical be alone, or the variable containing the fraction exponent to be alone. But since we have radicals on both sides, We just need one of the radicals to be alone on one side. So in this case, we have the square root of x plus 6 alone on one side. So the other side doesn't have that radical being alone, which means that we're going to have to take it to another level. So the first thing I'm going to do is get rid of my radical by squaring both sides. Now, what happens on the left-hand side is that the square will eliminate the square root, leaving me with x plus 6 equals. But on the other side, because I have this minus 3, this is actually going to be a perfect square trinomial. Technically, what this means is the square root of 11 minus x minus 3 times itself twice. So that means that we're going to have to FOIL it or use your patterns just like we did in our warm-up for today. I'm going to start off by FOILing it so that you guys can see what will happen, and then in the other examples we'll do we'll use our patterns. And that'll help us to make these problems a little bit shorter. So I have x plus 6 is equal to, I'm going to distribute the square root of 11 minus x times the square root of 11 minus x is equal to the square root of 11 minus x squared. Whenever you multiply two things that are exactly the same to each other, we're going to end up with a squared answer. Then I'm going to multiply the square root of 11 minus x times negative 3, so that's minus 3 times the square root of 11 minus x. The negative 3 times the square root of 11 minus x is minus 3 times the square root of 11 minus x. Then negative 3 times negative 3 is positive 9. So what I did here is I FOILed my parentheses, being as careful as I possibly could. Multiplying the first term times the first term, the outer times the outer, the inner times the inner, and the last times the last. Next, I'm going to combine my like terms and eliminate anything that makes sense for me to eliminate. So the square eliminates the square root, and I have like terms in the center. So I have x plus 6 is equal to 11 minus x minus negative 3 minus 3 is negative 6 times the square root of 11 minus x plus 9. At this step, I'm going to combine my like terms. 11 and 9 I can combine. I can't combine the 6 because the 6 is attached to the square root. So 11 plus 9 is 20. So I have x plus 6 is equal to 20 minus x minus 6 times the square root of 11 minus x. So what I want to do now is I need to get this root alone. So the way to get that root alone is to get rid of this 20 and this x first, then divide both sides by negative 6. So I'm going to subtract 20 on both sides, and I'm going to add x to both sides. By doing that, we now have 2x minus 14 is equal to negative 6 times the square root of 11 minus x. At this step, you have a couple choices. You can divide everything by negative 6, or because the main operation is multiplication, you can, if you want, simply put parentheses around both entire sides and square both sides. You just have to be careful if you choose to do that. So I'm going to do that just so that you guys can see what will happen here. So this is going to go into the next line. So 2x minus 14 squared, that's going to turn into a perfect square trinomial. So what that's going to be is I'm going to use my pattern like I did up in our warm-up. 2x squared is going to be 4x squared. Minus, because that's the sign in between. 2 times 14, that is that's 28. 28 plus 28 is 56. So that's minus 56x. And then 14 times 14, that is 196. So plus 196. This is equal to, I'm going to square each piece. Negative 6 squared, that's 36. And the square root of 11 times x, the square eliminates the square root, leaving me with times, and you have to put that into parentheses, 11 minus x, because that didn't eliminate the multiplication. So you have to be very careful. Next, I'm going to distribute that 36 to each term, and I have 4x squared minus 56x plus 196 is equal to 36 times 11 is 396 minus 36x. All right, at this step, because this is a quadratic equation, I'm going to bring the 396 to the other side and the 36 to the other side. I'm going to subtract 396 on both sides, and I'm going to add 36x on both sides. What ends up happening here is that the 396 and this 36x's cancel out, and we're left with 4x squared minus 20x minus 200 equals 0. Now, these are larger numbers, and they all have at least a 4 in common. So what I would recommend that you do is you factor out a 4, and your leftovers will be an x squared minus 5x minus 50. And that's a lot easier of a problem to factor. So I'm going to keep the 4 on the outside, and I'm going to break apart the quadratic into 2 parentheses. Splitting apart the x squared into an x and an x, I need to figure out what 2 numbers multiply to equal negative 50, but together add to equal negative 5. And that is a minus 10 and a positive 5. So that means that x equals 10 or x equals negative 5. So now I need to check my answers back into the original problem. So I'm going to check 10 first, and anytime that I see a square root equal to a negative number, I know automatically it's not going to work. So I'm going to write the square root of 10 plus 6, is that equal to the square root of 11 minus 10 minus 3 on the outside. So the square root, 10 plus 6 is 16, so that's the square root of 16. 11 minus 10 is 1, square root of 1 minus 3. Is 4 equal to 1 minus 3? No, it is not. It's equal to 1 plus 3. So in this case, we know that x equals 10 is not our answer. So now let's go ahead and look at negative 5. So I'm going to write the square root of negative 5 plus 6. Is that equal to the square root of 11 minus negative 5? So there's going to be a minus negative right there that's going to turn into a plus, and then minus 3. So is the square root of 1 equal to, this is a negative negative making it a plus, 11 plus 5 is 16. The square root of 16 minus 3. Is 1 equal to 4 minus 3? Well, yes it is, so our answer is x equals negative 5. So as you can see, there are a lot of steps when it comes to solving these problems. You have to be very deliberate with every single step, and you need to have confidence going into each step. So just go one step at a time. It brings everything that we've learned all together. And let's go ahead and try number 12. The way to kind of eliminate steps is to know your perfect square trinomial patterns to eliminate some of the work. That would certainly help you out. Let's go ahead and look at problem number 12. Now with problem number 12, we have a root that's alone on one side. But I'm going to be very honest with you. It would probably be easier to have the x minus 4 being alone on one side instead of the square root of 5x being alone on one side, just based on the numbers. If you don't see that, then that's fine. You can certainly solve it the way that it's written. But I think that in terms of a strategy, if you see a number that has a plus or a minus underneath the root, or a term that has a plus or minus under the root, get that part alone instead of the other part that has no plus or minus underneath. So I'm going to start off by subtracting 4 on both sides. And I end up with the square root of 5x minus 4 is equal to the square root of x minus 4. I'm going to square both entire sides, and I'm going to use that perfect square trinomial pattern. So what that means is that I'm going to take my first term and I'm going to square it. So that's going to be the square root of 5x squared. Then I'm going to multiply my two terms together, where my sign in the middle is going to be a minus. 4 times the square root of 5x doubled is going to be 4 times the square root of 5x plus 4 times the square root of 5x equals 8 times the square root of 5x. Then negative 4 times negative 4 is 16, so I'm going to write plus 16, and that's going to be equal to, the square eliminates the square root, leaving me with x minus 4. Over here, the square will eliminate the square root, and if you saw that from the beginning and you don't want to write that step, that's perfectly fine. Just be careful on how many steps that you actually eliminate. So now I have 5x minus 8 times the square root of 5x plus 16 is equal to x minus 4. I need to get this root alone with the number next to it, so what I'm going to do is subtract 5, I'm going to subtract 5x on both sides, and I'm going to add, I'm going to subtract 16 on both sides, excuse me. And by doing that, we have negative 8 times the square root of 5x is equal to negative 4x minus 20. Now at this step, you could divide out a 4 because every single term has in common a 4. You could do a lot of different things at this step. What might be helpful is to simply say, okay, since the main operation between negative 8 and the square root of 5x is multiplication, I can simply put parentheses around both entire sides and square both sides. So what we end up with is 64 times the square eliminates the square root, and we have times 5x is equal to, and in this case we have another perfect square trinomial. So you have to be careful here. You can use the pattern or you can expand. You can expand using the pattern, or you can write it out using FOIL. I'm going to use the pattern because I want to save time and space. So here's the pattern once again. Negative 4 squared, that is equal to 16. So I have 16x squared. Negative 4 times negative 20, so this is going to be negative 4 times negative 20 is 80, and then 80 plus 80 is equal to 160. So that is going to be plus 160. And what makes it a plus 160 is the fact that both of these terms were minuses, so that's going to make that a plus. So we have plus 160x, and then we have negative 20 times negative 20, which is positive 400. Okay, next what we want to do is I'm going to distribute the 64 to the number 5, and 64 times 5, that's equal to 320. So I have 320x is equal to 16x squared plus 160x plus 400. I now need to bring that 320x to the other side by subtracting it. So I'm going to subtract 320x on both sides so that I end up with an equation equal to 0. And I'm going to bring that up here. So I have 0 is equal to 16x squared minus 160x plus 400. Now these numbers are huge, so it might be in our best interest to simplify them. And I believe that 16 can go into every single term, so I'm going to factor out a 16. So I have 0 is equal to 16 times x squared minus 10x plus 25. Now, x squared minus 10x plus 25, that's a perfect square trinomial, but if you didn't see that, you can simply break it apart into 2 parentheses, splitting apart the x squared into an x and asking yourself what 2 numbers multiply to equal 25, but together add to equal negative 10. So that's going to be a negative 5 and a negative 5. So that would mean that x is equal to 5. That's our only solution that we need to check. So I'm going to check x equals 5 back into the original problem. So I have the square root of 5 times 5. Is that equal to 4 plus the square root of 5 minus 4? Is the square root of 25 equal to 4 plus the square root of 1? 4 plus 1 is certainly 5. So we know that x equals 5 is our answer. So now we have example number 13. And in example number 13, if you wanted to pause the video to try this one on your own to see if you have figured out how to solve these problems, that might be a good thing. If you don't feel comfortable with trying this problem on your own, then we can certainly go through that. But I'm going to stop the video right here, and I want to solve number 13 in class when I see you next. So we'll do that number 13 problem together, but I want you guys to try that problem on your own before the next time I see you. So that is the end of today's lesson. Please feel free to email me if you have any questions over anything. Otherwise, I hope you have a wonderful day.